So here is another question on properties of electromagnetic waves. So it is given that a plane electromagnetic wave, it travels in a particular medium which has a relative permeability of 1.61 and a relative permittivity of 6.44. If the magnitude of magnetic intensity at a particular point is 4.5 into 10 to the power minus 2 Newton per meter, what will be the approximate magnitude of electric field intensity at that point? Okay, so what is given here is that we have a particular medium, okay, for a given medium. It can be anything. The relative permeability, okay, mu r, that is equal to 1.61, okay, and the relative permittivity, that is equal to 6.44, and the magnetic intensity is basically H. If you have some idea about the parameters associated with magnetism, magnetic intensity, intensity of magnetization, susceptibility, all that, then you will be aware of this. So H, the magnetic intensity, that is equal to 4.5 into 10 to the power minus 2 Newton per meter. So here we can calculate the magnetic flux density B at that particular point using the formula B is equal to mu m H, which is equal to mu 0 mu r into H, where mu 0 is the absolute permeability. Okay, relative permeability is given, H is given, so the magnetic flux density at that particular point in the medium can be calculated, and that will be equal to 4 pi into 10 to the power minus 7 into 1.61 into 4.5 into 10 to the power minus 2. So the magnetic flux density, it is coming around 9.1 into 10 to the power minus 8 Tesla, this much. Okay, this is the value of magnetic flux density at that point. Then the velocity of electromagnetic wave. So it is for a given medium, the velocity of electromagnetic wave is given by 1 by root over of permeability of the medium and permittivity of the medium, which is equal to 1 by root over of mu m is mu 0 mu r, and epsilon m is equal to epsilon 0 epsilon r, product of absolute and relative permeabilities and permittivities. That gives the permeability of the medium, permittivity of the medium. So if we rearrange it, it will be coming around 1 by root over of mu 0 epsilon 0 into mu r epsilon r. So if you remember, 1 by root over of mu 0 epsilon 0, that is equal to C, 3 into 10 to the power 8. So here this much portion, okay, this much portion, that will be equal to C. So this Vm will be equal to C by root over of mu r epsilon r. Okay, So all the parameters we know, mu r is equal to 1.61, epsilon r is equal to 6.44, c is equal to 3 into 10 to the power 8 root over of 1.61 into 6.44, that is equal to, it is coming, the velocity is 9.31 into 10 to the power 7 meters per second. That is the velocity of the electromagnetic wave in that particular medium. Again, from here we will be using another relationship. See, it is all interconnected. One formula leads to another. So if you remember all the formulas, then you will be able to connect the dots and you can get the result. So the ratio of electric and magnetic flux densities at any particular point in a medium, that gives us the velocity. So here at that particular point, the electric field and the magnetic flux density, the magnetic field, that value gives us the velocity of the electromagnetic wave at that particular point in the medium. So EM is equal to VM BM. VM we have already calculated, 9.31 into 10 to the power 7, and magnetic flux density we had already calculated previously. This is basically BM. Okay, this mu m h or mu 0 mu r h. Okay, this is BM. Okay, so simply we'll be putting this value here, 9.1 into 10 to the power minus 8 here, 9.1 into 10 to the power minus 8, so it is coming around 8.48 volt per meter or Newton per coulomb, in whichever units you want to express it, it will be alright. So this, which was asked to find the electric field intensity at that particular point in the medium, which is 8.48 volt per meter or Newton per coulomb. Okay, so this is the thing. So here so many things were interrelated. First, using this formula, Bm is equal to mu m h or mu 0 mu r into h, we calculated the magnetic flux density at that particular point in the medium. Okay, this is the first thing we got. Then using this relationship for the velocity of electromagnetic wave in terms of the permeability and permittivity, we calculated the velocity of the electromagnetic wave, which is this here. And then again, using the relationship between electric field, magnetic field and velocity, we calculated the electric field intensity at that particular point in the medium. Okay, this, we got this. Okay, so friends, I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.